Welcome everybody here and online, of course. Let me step in view. My name is Martijn Mulder from Sogeti, and together with Bogdan, welcome.
Thank you, Martijn.
We will tell you today everything about
secure GitHub Actions. Well, as much as we know about them. Thank you for the invitation, Martijn. I'm from Microsoft. Maybe just a little bit of a bio slide about us. I'm a cloud solution architect working with Microsoft, and I'm specialized on Azure infrastructure and DevOps practices. I'm Romanian. I was born in Romania, but living in the Netherlands and enjoying this beautiful country for about 4 years. And in my daily job, I only interact with partners and less with customers.
Yeah, great to have you here. And I help our customers with their teams, development teams, DevOps, GitHub. And for our company, I'm also one of those who are managing our GitHub platform. So let's take it away.
Yeah. For today, we have a few topics on the agenda. We also have a little demo to present during our deck. We're going to have a look at what enterprise DevOps looks like, and then we're going to have, let's say, a helicopter view about how people can roll out certain resources in Azure from a management point of view, and then getting closer and closer until they get rolled out in Azure. Of course, we need to talk about GitHub, because you'll understand at the end of the slide why, at the end of the presentation. We're going to have a look at GitHub secrets and how they're being handled, what is the magic behind. We're going to speak about a technology called OpenID Connect. We're going to run through some topics related to advanced security. And then I think the last one is the most important one, choosing the best platform for your future.
So if you have any questions during the presentations, please keep them to the end, and we will handle them then, including the ones online.
Yeah, thank you.
Yeah, so with GitHub, Microsoft, and Sogeti, we have been working together on enterprise DevOps before. In 2020, we started with the enterprise DevOps report, where we had 6 areas of IT, governance, security, etc. And really look into how successful companies approach the DevOps and what made them successful, what culture patterns followed by those, and how they really achieve high performing. Also the strategies implemented by them to build continuous governance and oh, there's sorry. Security, quality, and compliance, of course. And after that, we started on the 6 tips to integrate security into your DevOps practices. And those 6 tips were to really develop a security-first company culture. So this book, and we take you into how you can proactively secure your code, workflows and infrastructure, how to provide your teams with shared tooling and best practice to end-to-end visibility and traceability, and also how to leverage improved insights and policy automation. So that's really in this book. And beginning of this year, we published the book Securing Enterprise DevOps Environments Together. And in this book, we really focused in, hey, how are you going to secure the complete environment of your developer? So his system, his DevOps toolchain, and this landing zone. And if you look into a slide of that book, you get this overview. On the left, you see the developer environment with possible threat attack vectors. For example, your network. These days we work from home a lot, or maybe on the airport, or at your Starbucks. Huh? And how can you keep that secure as a company? But from us, from our point of view, it's more important on the top one and the application environment. So the top one is the DevOps platform, your GitHub, your GitHub secrets, your automation, how you apply that, or your application environment, your landing zone, and which threats could surface that. So today, we will talk about this.
Yeah. Thank you, Martijn. So as promised at the very beginning, we just want to start with the helicopter view. We want to see what people should start with in Azure. And we say at Microsoft, you should start with the management groups. Of course, we're going to get down by the end speaking about the, GitHub and how secrets are handled. But until we get there, we need to understand why do we need those. And the reason is that in Azure, you can deploy a lot of resources. You can deploy virtual machines, public IPs, all sorts of networking configurations, so on and so forth. But before you create all those, you have to think a little bit what's the bigger picture and how logical are all those resources organized in Azure. So we invented this notion called Azure Management Groups, where you can nest various subscriptions under a logical group that can have its own policies, it can have its own credentials if you want, you can authenticate, or you can do a lot of things with them in different manners. So the interesting part is that, of course, these management groups, as you can see here, they can be nested one under each other. They can be grouped for different regions. They can serve different purposes like development and test or production environments or free or maybe just a very expensive enterprise agreement subscription. So we have to see this, right? We have to build this picture from the above. Once we start defining all those management groups like platform, identity, management, connectivity, so on and so forth, then we start bringing all these subscriptions under them, right? So we start thinking, under the identity subscription, we should create some domain controllers maybe. Under the management subscription, maybe a Bastion host, something just to let us around in Azure, but not too much. And these two should not interfere necessarily one with each other. Most important, we want to make sure that the connection to deploy this is also extremely well secured. Imagine how much would it cost you if you just leave access to your identity subscription out in the internet, or you make your domain controllers available from the internet. Not a good thing, trust me. And also, because developers are, let's say, the drivers of the tomorrow, we just want to make also room for them to make mistakes. We want to let them invent, create with purpose. So that's why we start from this. This is what we want to achieve on the long run, but we also have to have a canary zone, a canary landing zone. So in this place here, you can just let them roll out infrastructure more easily. You can let them roll and test solutions without too many restrictions. So whatever is policied, whatever is, let's say, secured in that area can be maybe a little bit less secure in this area. This can be the production of tomorrow. So we need to make room all the time for people access and for automation access. In the very end, well, okay, things are getting up, solutions are being built. It starts to look like this. It becomes massive. So when you're thinking at one developer, what a developer is doing on a day-to-day basis is creating the code for this little thing here. But maybe this application that's being created here requires access from to one of those domain controllers over there. Maybe it requires access to a connectivity subscription or to a sandbox. You never know. So it's all the time a very, very, very big picture. So this is what we at Microsoft call the well-architected framework. But it's not only well-architected framework, it's also well-managed, well-secured framework. Because this is the big picture where you want your solution, your intellectual property to go, and we want it to be very, very secure. The way your intellectual property gets there should be secure as hell.
It would be great if you could tell us about that, Bogdan.
Well, the question behind the question is, how do we get there, right? How do we roll out our code, our ideas, our solutions, right, in there?
I'm a developer. I want to deploy. I want to press push. Come on.
Yeah, exactly. We want to push. We want to have our solution fastly rolled out to Azure. So we need that fast pace, fast rollout of infrastructure. So we at Microsoft, initially, back in the days, we had TFS, we had...
Yeah, we had Visual Studio Online first.
Yeah, exactly.
Visual Studio Team Services. Now we have Azure DevOps. So.
And what's next?
The sticker on my laptop?
The sticker on his laptop, indeed. And unfortunately for the people who are online, you guys cannot get it. I'm very sorry for that. But for the people in this room, if you want a sticker like that, it's there, back there on the table. When you go out, just grab one. It's just like that on the back of his laptop. So yeah, the question is, well, what's GitHub, right? It's just a platform that was invented or Microsoft bought it back in the days, and what's Microsoft doing with it, and how can it help us? Well, long story short, DevOps is not necessarily a competitor. Azure DevOps is not necessarily a competitor of GitHub. There are two different platforms, they serve different purposes, and luckily, they also integrate one with each other. But I like seeing the big picture. Seen from the above, GitHub becomes the very best platform to accelerate and secure the software development. We're going to have a discussion about that a bit later. So we're very interested about this mainly, right? Code to cloud. We want code, we want to write that code and ship it very fast in the cloud. Well, it's all about the other things around. We need to take care a lot about security, about team collaboration, how do we work with others, and how do we even recruit talent from the market. And GitHub, right? There are like 84 million contributors, active ones. So I think that's quite a lot of talent over there. So that's why GitHub is now part of, let's say, Microsoft is like a daughter company now. But we focus on a lot of things, and one of them is, for example, the security and compliancy part.
Yeah, this is part of our presentation, of course, and security and compliancy with GitHub is one of the major improvements for me, at least, to really work with GitHub.
Yeah. I've worked my whole life with DevOps, VSTS, TFS, all those services. But now I'm like, GitHub is fitting better in my mindset. It's like, it's more agile, it's better fit for the purpose. It has a global community behind it. It can do all sorts of pattern-based analysis. So a lot of money have been invested into it. So you can see, if you're using GitHub, that you can get a lot of alerts and advisories based on what code is being uploaded in there, whether code is infrastructure as code or the code itself. And if we look at the whole picture, probably we as developers, we only see that part, the coding part of it. But in reality, there is more. That code that we are building needs to be built somewhere. It needs to be tested before it gets anywhere. It needs to be released. It needs to be put in a bag before you go home with your shopping cart. Then it needs to be deployed, right? So you have to take that shopping cart and go home with it and then unpack it and see if it's everything fine. And once the code is there, you need to operate. And you need to cook your own food, right? Once you came from the supermarket. So that's the operation part. Monitoring and planning also becomes an integral part of GitHub. And the cool thing is that, yeah, it's a platform made to reach to all the other major platforms, including Azure itself. But we're not limiting ourselves to Azure, right? We can definitely go anywhere.
Yeah, so besides that, we have obviously also features for team collaborations. So the most important one probably is pull request and discussions around it, and really improve the quality of your code as a team. So that's one of the most important parts. But therefore, we're here for GitHub Actions.
Yeah.
Yeah.
The reason why we are talking and we're bringing this to your attention is because we want to break those silos that usually exist in even in small organizations, we don't want people to be in their own little church over there. We want them to collaborate one with each other, but at the same time, we want to know what they're doing, so we need those teams insights, and we want to be secure once this thing becomes a habit on a daily basis. And I said earlier, developer talent, right? We need to acquire people from the market. We need to expand our businesses, so that's where the developers are, on GitHub. Trust us.
Are those your contributions, Bogdan?
I wish. Yeah, no, I wish. I'm probably nowadays more and more into PowerPoint, but and less in GitHub. And as per my background and also yours, and in general, we were like DevOps people, DevOps-minded people. So we want to automate everything. And then once we automate it, we need to ship it somewhere. Nowadays, GitHub has a very good interaction or integration, if I could say, with Azure. You can use federated identities, you can use automated workflows, you can make use of unified authentication, so on and so forth. Well, we're going to speak more in depth about that little part called unified authentication. We want to understand how we can secure at its best the communication between GitHub and Azure. How do we have that connection in the most or extreme way possible? So in the upcoming part, we're going to speak about secrets handling, right? Everyone looks at secrets just like the kids look at that little toy over there. But in reality, that's, for most of the hackers, the honeypot.
Yeah, there's a story here. And the story is that the leakage of secrets by developers is one of the easiest way for hackers to find a backdoor in your system. Yeah. Just by logging in into your system. Yeah. And we developers, we tend to put those secrets in our code. And if we do that, it might be in the private, but I have numerous occasions where they are published to open source and they are cloned immediately, and hackers have those secrets. Yeah. So today, after this session, I really hope you know how to handle your secrets well in GitHub Actions, because that's the top one priority for us to secure our environments.
How many times didn't we hear about, oh yeah, some secrets leaked, just a few millions down the drain. So easy. And so sad. So before we get to those secrets, we need to learn how some variables become secrets. Well, the simplest of all are the environmental variables. How do they get there? Well, we type them, right? Just as we see here in the picture. We either type them here at the environmental level, or we type them here, and this becomes the environmental variable for a job in a workflow, for example, or directly here in a step, right? So now we understand where those secrets can be placed as we speak. The catch is that at the moment, these secrets are not that secret. They're still hard-coded over there. So we say, okay, what do we do about it? How do we consume them? So if this wouldn't be enough, guess what? Some secrets, some variables, can be consumed from other jobs, from other stages. So if a secret is being produced at a previous stage, then it can be passed on to the next stage, the next job, right?
For example, you have your RM template, which deploys a storage account, and the storage account key can be output to your platform.
Exactly. And that becomes a contextual variable. This is how it's called in the world of GitHub. So now the question is, okay, fine, we got a lot of connection strings, we got a lot of variables, what do we do with them? Well, we have to encrypt them. And this is how they become secrets. Once they're encrypted and nobody can see them, they become secrets. So now, what are the secrets? Well, they're simply encrypted environmental variables. How they're encrypted? Well, the technology itself is called Lipsodium sealed box. And the most important part of it, well, this is the code that really does the thing. But the most important part is that only the recipient can decrypt these messages. So which means, in our case, that if we have a real example, if we have a job that executes on a GitHub runner, then, and it produces a secret, then only the next runner, it can be itself, it can be another one, only the next runner can pick up that information and decrypt it. Why is that? Because they can only be decrypted by the recipient itself, right? So this is really, really powerful. So you wonder, what is is it like this? How do you create those variables that become secrets? Well, there are multiple ways of getting there. One of them is GitHub CLI.
Yeah, that's a cool story because in my day-to-day job, we use those CLIs to really secure our environment. So we have a PowerShell script creating Azure resource groups, creating service principles in it, and really putting those service principles to GitHub secrets with the CLI. And no one knows the secrets, even our admin team doesn't. No one's have to enter them in GitHub, so it's all automated. So really cool to have. Some caveats, but I think you will mention that later on.
Yeah, in a few moments. So this is one way of creating those secrets, GitHub secret list or set or something like that. But if you don't necessarily want to recurse to that, then there is also a fancier way, the programmatic way, using CRUD operations on them, where you can create them, list or update them, read them, and everything is pretty well documented in terms of the status codes. So all you have to do is just use the right method and the right operation, and then you're going to get those secrets created at the GitHub level dynamically without anyone seeing those secrets. Okay, secrets. We've seen the bigger picture with the management groups, with all those resources. We know that we need some secrets somehow to get there. And the question is, well, how many secrets or how powerful that those secrets should be, or how many should we put in there? The answer is to how many, as few as possible. This is what we want. Not too many over there. So we want to introduce the notion of GitHub OpenID Connect, right? Which is an identity layer on top of the Auth 2.0 protocol. If all this information that you'll see in the upcoming slides will become maybe way too dense or very hard to see or to retain when you go home, probably if you've had a lot of sessions, you can review the video and see all the snippets that were in there. So what are the benefits of this new technology called OpenID Connect? The most important one is no or less cloud secrets. It's a very strong authentication and authorization management way, which means that a secret, a variable that's being created and then it's encrypted, it's only scoped to a particular repository, to a particular workflow. It's really, really teeny-gritty specified where it can work and how.
I think our security boys would love that.
Yeah, definitely. Ours does. Yeah, so we're just going to give you a short overview on how does this work. You don't have to remember this, but it's pretty much like this. You have here a cloud provider, and then you have here GitHub. In our case, this is Azure, and this is GitHub itself. And what does it happen over there? Well, the first one is establishing the trust here with the GitHub OIDC provider. So once Azure trusts GitHub and the other way around, then we have the trust mechanism in place. Then you have the token generation, which means that GitHub says, wait a second, Azure trusts me, the workflow instructs me to go and deploy something at a certain level. I have this bag of claims in my hand. Let me go to Azure Active Directory and say, hey, look what I have for you. Please give me that access token. So it requests a token from Azure Active Directory based on the trust that has been set up here. And once Azure Active Directory verifies that everything is okay, is all set, it grants a token. It's a very short-lived token. that is mainly used during the workflow, the action run. Of course, the obvious question is, why do we need something like this? First of all, the most important one is because we want to have a strong login. You'll understand why in just a few moments. In most of the cases, when authentication happens from an automated workflow, when authentication happens against Azure Active Directory, we're using a service principal. We're no longer using username and passwords because passwords are kind of obsolete. We have MFA, so it shouldn't be the case to just save them somewhere. So we have the Azure service principals. Oh, should be here. And they can also be automated using CLI tools. So there are two main ways to authenticate. The one that we want to avoid is this one. Using an SPN, SPN stands for Service Principal, that has a few details about it. It has a tenant ID, the realm where it exists. It has a subscription ID, where it's being granted to have access. It has a client ID, and it has a client secret. We don't want that secret. Imagine yourself coming up from a party at 3 a.m. in the night and say, ha, I have that secret. I know the client ID. I can start destroying everything at 3 a.m., right? Because
you should be asleep then.
You should be asleep, but maybe you're not and you're doing bad things. And how can we get over that? Well, exactly using federated ID credentials, where you don't need, if you look one-to-one, it's exactly the same thing, but the client secret is missing from here. I said earlier.
So in my example, I don't know the client secret, so I don't have to be afraid to be a bit drunk. But still, that secret has a time to live for max a year. And I need to rotate those secrets.
Yeah.
With this solution, I don't have any issues, and there's real trust. So that's a great solution.
Perceptually, that token that's being granted by Azure Active Directory only lives during the execution of the workflow. When the workflow is done, the whole CL box from the Ipsodium disappears and the token is no longer there. Nobody has it. Yeah? So also in the demo, that's going to come in a few minutes.
Yeah, you need to look at the time.
Yeah, I know.
Show us the money.
Yeah, show the money. We're going to do a few things. One will be the SPN registration. The other one will be setting up those federated credentials in Azure without creating the secret. And the last part will be, of course, to copy those important details and put them somewhere in GitHub, and eventually have a workflow running based on the secrets that we upload in there. So from a high-level overview, pretty much we're going to execute something like this. This is a very, very, very simple workflow in GitHub. And if you notice, if you're familiar with GitHub and workflow automation and everything, you notice that there are some permissions over there, which means that you allow the GitHub Actions itself to write that token that is being generated at the runtime and also read its contents, right? Read the contents that was coming from Azure Active Directory and then write it for the runtime. And then we just have two extremely steps. The first one is the authentication part, and the second one will be just getting some resource groups from Azure Active Directory, being pre-authenticated, only client ID, tenant ID, and subscription ID, no secrets. Yeah, so those are the important parts. And before we move to the demo, I just want to say that a very simple workflow, like you see here, it can be reused. So you may call that workflow, it's inner sourcing, right?
Yeah.
We want to have that workflow reused as many times, and you don't have to reinvent the wheel every time you do something. So, of course, how do you do that? You can just reference the workflow. There is a caveat there. At the moment, the workflow that you are referencing must be in exactly the same repository as the workflow from where it's being called from. It's a bit of, sounds like a little bit of a limitation, but the product groups are working on improving that. Or you can call a workflow that exists in a public repository somewhere else, in somebody else's backyard, if your organization allows to make use of publicly reusable workflows. If you want to learn more about what are the existing limitations and what's being worked on, please review this video of this recording and follow this link. You'll figure out what's coming there. Okay, so we're getting to closer to the demo session. Ooh, we're running a bit.
Yeah, you have time. You have 5 minutes for your demo.
Yeah, thank you. Very generous, huh? Let's see. I hope you can all see my screen. I think I should make it
a bit larger.
A bit larger, yeah? Okay, great. So, I've told you a lot of things. I'm not sure, are you familiar with Azure, with the Azure portal? No? Ish? No? A little bit? Okay. So, super short introduction because we definitely run out of time. We have 15 minutes left in total. But this is Azure Active Directory. This is how it looks. We just go here to the app registration, and we're just going to create a new application. We're going to call it Sogeti.
This normally will be done by your app teams.
Platform teams.
Platform team, your landing zone. We won't have any rights in our own corporate directory to do this. So
yeah, exactly. So we've just created an application, a registered application in our Azure. It's the equivalent of a user, but a user that is not backed by a human being, but it represents a solution, an application, something like that. And then once we go here to the certificates and secrets, usually we can create a new client secret. No, we don't want to do that. We can create a certificate also for authentication. It's significantly stronger than passing over a secret. But what we want to do is to do this, to have federated credentials. So we're just going to click here on add a federated credential. We're going to choose GitHub Actions, deploying Azure resources, and we're going to choose the organization name. Here we're going to call this IT Delivery. This is my organization name, and then repository name. And I'll just create a new repository here.
So this is GitHub for those?
Yeah, so this is an interface of GitHub. I've been pre-authenticated just to skip a lot of dead time. I will just say here QXDay. That will be the name of the repository. It's going to be private. Let's also initialize it to have something over there. And the repository is created. So all we need to put here is the name of the repository. So that's QXDay. Day and entity type, we want to protect the rollout to a specific environment. That environment is being stored directly in the workflow. And when it comes to the environment, let's just say prod. It's something that we...
GitHub facilitates more environments than just one.
Yeah, of course.
And you can name them in GitHub yourself, so you can create a dev, acceptance, production environment.
QXDay repo, something like that, doesn't really matter, just something here. Okay, so we have the federation created. All we have to do right now before we start rolling out the pipeline, we have to give this application called Sogeti, in our case, we want to give it permissions over one of those management groups that I've shown you earlier. So I just have one management group around just for fun. So I'm just going to go here to access control, role assignments, and I'm going to click on add, role assignment. In this case, I will set it to owner because in certain cases you need to enable certain features which are only available if you have the role permission, the owner permission. When it comes to the members, I'm just going to look for that Sogeti application that I've previously created. It's here, okay, review assign. And 1 year later, here we have it. It's going to be set as the owner for that one. Which means that at the moment, whomever has the credentials of that application, you see there, it is an application, can authenticate and can do pretty much everything with that subscription, can wipe out everything. So it's an app here. Now, what do we do with it? We go back to it, because we're going to need certain details about it. We're just going to go here to app registration. And this is the app, and we will need all these from here. Application ID, application ID, directory ID, or tenant ID, and the subscription. Again, just for simplicity, I've pre-saved all the information that I need in a variables file. So this would be the client ID. And the question is, what do we do with... Oh, okay. Sorry. What do we do with all these? Well, we're going to save them at the repository level back in GitHub. So go to GitHub, go to this repo, and go to Settings, Secrets, Actions. We want to set a minimum set of secrets available only at the Actions level. So I'm just going to create here a few repository secrets. I'll do my best to be as quick as possible and not bore you with dead time. Like this, tenant ID. Hard to see the dead space, huh? And there's a secret. A new one. That's the boring part.
Yeah, I've created a script for that.
Yeah, exactly. And it can be automated, right?
Yeah.
But at certain moments, you just
They
need
want to see you doing it in real time. Yeah. And see you sweat.
And maybe a blue screen. You don't know. Sure. And then the subscription ID or the management group ID. So once we have these three secrets saved there, which is this one, what we can do, okay, so there, do I have a space here? No. Okay.
All looks fine to me.
Yeah, it looks fine, right? Yeah. Okay. So now I have to go back to the code of the repository and just, I can say, where is it? Add a file, create new file, and I'm just going to define my file, which will be the workflow definition itself. I'm going to place it with this name in this directory in the root of the...
Yeah. So workflows need always have a predefined directory.
Yeah, exactly. We're just going to copy the code for it, of course. That's what we do for a living. We do copy and paste. Okay.
So the cool thing you already see in this Java file is that he used the secrets dot client ID, tenant ID to really use them.
Yeah.
And
you can see them here, right?
Yep.
So these are the contextual variables that we had a look beforehand. So whenever this workflow will start, we'll have a look at the secrets and we'll pick up all of them and it will pass them in to this step here, which is called Azure Login. It's well documented, and it will do its job.
And this you will use for all your secrets, your connection strings to your database, to your test provider, to whatever, do your dashboarding, put them in here and reuse them. And the cool thing is here, if you look into it, also in the debug window, these are asterisks.
Yeah, exactly. So those secrets that we've uploaded in there, I will never be able to retrieve them, ever. So they're there. Okay, our workflow finished successfully, as you can imagine. But what's very important here is that what we've done was a successful login, and then we had another step. Maybe it's way too much, it might be a mouthful. But after that, we ran a PowerShell script that just iterates through all the resource groups that I have in that subscription, and is listing them here one by one. Trust me, if the first part here would not work, the login part would not work, the second step will fail.
Like I said, our security guys would love this.
Yeah, exactly. At the moment, there is no more secure way than this of authenticating between anywhere into Azure. This is the most strong authentication that exists.
So, can we get back to the presentation?
Absolutely.
Because you took 3 minutes more.
Excuse me.
So, the next part, I think it's also good to quickly provide you some insights to, and that's to GitHub Advanced Security.
Yeah.
And what it brings to us is really great features of dependency scanning, code scanning, and secret scanning. And I believe we can dive in directly to the dependency scanning. So the cool thing about this is it really secures your code from dependency vulnerabilities, which are being found in the Micro database or in GitHub itself or open source out there. And when you already have your code in your repository, no one's looking at it. For example, if it's in production already, those pop-ups of security vulnerabilities will still come up.
Do you have an example for that?
Yeah, maybe we all know Log4j.
Yeah, exactly.
And the problem with Log4j was that no one knew if his code was affected.
Yeah.
And this is really powerful for that, and it's really standard in the platform for GitHub Enterprise users. So it's really cool to have. But that's not all that's with GitHub Advanced Security. Because code scanning is there.
Exactly. It's very powerful. It's a very strong tool. You can scan the code as you type it, and it will give you warnings. It will tell you about what's going wrong, right?
And I need to say that this is a premium feature. So if you really want to use this with your client, please connect with me. We can set it up. And it's also based on GitHub Actions itself, again. So it uses the same thing, but the code QL is really powerful and is injected when compiling your code. So it's really, really cool to work with.
Yeah. So we have dependencies, right? Code that exists somewhere else. We have the code itself, the code that we're running, and we also have the secrets scanning, right? We developers, this is what we do, right? We kind of hard code certain credentials over there just to let it work, like just make it work for the moment, and then we forget about them. So this is also one of those premium features.
Yeah, and this also has some functionality like OAuth scanning, and etc. So really cool. SQL injection is getting detected with this. So if we want to have that with your client, let's connect with us.
Yeah, exactly. Our details will be on the last slide. Something also worth mentioning is that now, the policies that you can set on top of subscriptions and management groups, they can also be referenced directly from GitHub. So now there is a connection. So you don't necessarily have to roll them out in a very, let's say, fancy way. Directly point out to the registry that has them, and they just work.
So we go to the questions.
No, we still have a debate.
That's a question.
Yeah. This is the biggest question.
Yeah.
What is the best platform? What should you choose? And I'm going to try, just to be conscious of time, I'm going to try to go as soon as possible, as fast as possible. We have GitHub and Azure DevOps. They both have repositories. They both are able to do CI/CD, and they both handle code packages. And I will let you read this as fast as you can in your mind with your own voice.
So, why should we use GitHub?
Well, there is a big, let's say, discussion. There is a lot of work being put into, let's say, both platforms. Both will be, let's say, supported and future-proof. There is also a battle card around them, like who wins in certain scenarios. And I'm also being conscious of time, and I'm going to go as fast as possible. So, Azure DevOps versus GitHub, yellow wins.
So boards.
Boards, definitely. Azure DevOps wins with its boards. It's outstanding. The next one will be group thinking.
Yeah, discussions.
Discussions,
yeah.
GitHub discussions, right?
Repos.
Repos, well, they're kind of both almost at the same place, but GitHub has advanced the advanced security
Dependencies.
features. Yeah, exactly. Everything that we spoke about. Code spaces will never come to Azure DevOps. Maybe I'm speaking big words, but I don't ever think it will come. Advanced security, both platforms can make use of advanced security, but it's native in GitHub, natively integrated. Packages, there is a reason why GitHub packages are a little bit better than DevOps. CI/CD, by far, GitHub is the clear winner there. Workflow automation, also GitHub Actions, significant better.
So to conclude, if you start a new project, use GitHub Actions and have Azure DevOps boards on the side?
Yeah, something like that, right? Integrate both of them until GitHub will catch up, I would say.
Okay. So, boost your impact, apply these practices. Are there any questions from the audience? From the online here?
Yeah.
Is the presentation going to be distributed?
The question is, who will distribute the presentation? I think QX Days has it on the website, so...
Last year, it didn't arrive. They didn't.
I will get after that, so...
You'll follow up on that?
Yeah, I will follow
Okay.
up. I will make sure that happens.
Okay.
Yes, there's a lot of details in here. We know that, but it's really important. If you need to do secrets, don't put them in the code.
Exactly.
Put them in your secrets. There are multiple ways for authentication, and that are the big takeaways for today.
Federated authentication, federated identity, and never save connection strings or anything in there. And
also,
with that...
Also not for test.
Yeah, not for test. Thank you so much. That's been it. Thank you.